In this video, I am going to deal with the relationship between zeros and coefficients of a polynomial. First, you have to go through my previous video, zeros of a polynomial, to understand the concept of zeros, and then you have to go through this video. So, now, if alpha and beta are the zeros of the quadratic polynomial p of x is equal to ax square plus bx plus c, where a not equal to 0, and x minus alpha and x minus beta are the factors of p of x, then quadratic polynomial means degree, a polynomial having degree 2 is known as quadratic polynomial. So, quadratic polynomial can be represented as ax square plus bx plus c. Here it is given that alpha and beta are the zeros of this quadratic polynomial ax square plus bx plus c. Then x minus alpha and x minus beta are its factors. It can be represented as kx square minus k into alpha plus beta into x plus k alpha beta. So, your coefficient of x square, that is a, is equal to k. Comparing these two, we will be getting it as coefficient of x square, which is a, is equal to k. Coefficient of x, which is b, which is equal to minus k into alpha plus beta, and coefficient of c, that is a constant, which is equal to k alpha beta. So, relationship between zeros and coefficients of a polynomial means that you have to obtain sum of its zeros and product of its zeros. Sum of its zeros is given as alpha plus beta, since alpha and beta are the factors of p of x. X minus alpha and x minus beta are the factors of this polynomial. So, sum of its zeros alpha plus beta is equal to minus b divided by a. That is minus of coefficient of x divided by coefficient of x square. Product of its zeros is given by alpha beta. Alpha beta is equal to c by a, that is a constant term c divided by coefficient of x square. So, you have to remember these two equations while you are going for the relationship between zeros and coefficients of a polynomial. Let's solve this by means of problems. First question. Find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationships between zeros and coefficients. For obtaining the zeros of this quadratic polynomial, you have to factorize this polynomial. So, first go for factorization. Here, x square plus 7x plus 10. You know that coefficient of x square is 1. So, you can directly go for applying sum of polynomial is 7 and product of polynomial is 10. So, you have to find two numbers in such a manner that whose sum is equal to 7 and whose product is equal to 10. Here, you can directly go for taking 5 and 2, since 5 plus 2 is equal to 7 and 5 multiplied by 2 is equal to 10. So, you can write it as x square plus, split this 7x term, 2x plus 5x plus 10. Then you have to group this into 2. Then you have to take one common factor from both. Here x is a common. So, x plus 2 plus here 5 is common. So, 5x plus 2. So, here x plus 2 is common, another factor is x plus 5. So, you got two factors x plus 2 and x plus 5. Now, your zeros of this are x plus 2, 0 is minus 2, and for x plus 5, 0 is minus 5. So, x is equal to minus 2 and x is equal to minus 5. Then you have to verify the relationship between zeros and coefficient. So, you have to go for sum of zeros. Sum of zeros is equal to minus b by a. Here your b is coefficient of x, which is equal to minus b by a. Here you have to take a negative sign, so which is equal to minus 7 divided by a is 1. Then here also you have to consider 2x term. Verify this with the relationship between zeros and coefficient. So x is equal to minus 2 plus minus 5, which is also equal to minus 7. Then you have to verify the product. So product of zeros is c by a. Product of zeros equal to c by a. Here c means constant term divided by a means x square term. So 10 by 1, which is equal to 10. You can verify here also product is equal to minus 2 multiplied by minus 5, which is also equal to 10. So your both answers are correct. Second question. Find the zeros of the following polynomials and verify the relationship between zeros and coefficients. 6x square minus 3 minus 7x. Here it is not in order, so you have to first make this as an order. So here you can write it as 6x square minus 7x minus 3. Now you can consider zeros of the following polynomial. So here x square term is not equal to 1, so you have to go through that x square term into this constant term. So you have to get p plus q is equal to minus 7 and pq is equal to 6 into 3, which is equal to minus 80. Here you can consider two terms 9 and 2. Minus 9 and 2. Minus 9 plus 2 will give you minus 7 and minus 9 multiplied by 2 will give you minus 80. So you can rewrite this as 6x square minus 9x plus 2x minus 3. Now you can group this into 2, taking common factor outside. Here 3x is common, so I can take it outside. Remaining term 2x minus 3. Here 1 is common, so 2x minus 3. So I got the factors as 2x minus 3 and 3x plus 1. X is equal to 2x is equal to 3, x is equal to 3 by 2, and here x is equal to minus 1 by 3. Now your zeros are 3 by 2 and minus 1 by 3. So you have to check for sum of zeros. Sum of zeros is equal to minus b by a. Here you can go for sum of zeros as 3 by 2 plus minus 1 by 3. Taking the LCM, 9 plus minus 2 by 6, which is equal to 7 by 6. Your product of zeros is (3 by 2 multiplied by minus 1 by 3. 3 cancel, so it is equal to minus 1 by 2. So you can check now for product of zeros and sum of zeros. Here you know that your sum of zeros is minus b by a. Minus of 7 by 6, which is correct. Here you got it as 6x square minus 7x minus 3, which is correct. And your product of zeros is C by A. C by A is minus 3 by 6, cancel, minus 1 by 2. So both your answers are correct. Second question is 4x square minus 5. Find the zeros of 4x square minus 5 and verify the relationship between zeros and its coefficients. Here 4x square minus 5 can be factorized as 2x plus root 5 multiplied by 2x minus root 5. Since it is of the form a square minus b square is equal to a plus b into a minus b is equal to 0. So 2x plus root 5 equal to 0, x is equal to minus of root 5 divided by 2. Similarly, 2x minus root 5 equal to 0, x is equal to root 5 divided by 2. Then your sum of zeros, that is alpha plus beta is equal to minus of root 5 by 2 plus root 5 by 2, which is equal to 0. Your alpha beta is equal to root 5 by 2 multiplied by minus of root 5 by 2, which is equal to minus of 5 divided by 4. You can verify your answer. Sum of zeros is minus b by a. Here b is absent because coefficient of b we can take it as x coefficient only. Here x coefficient is absent. So sum is equal to 0 and product of zeros is c by a. C by a is constant term, that is equal to minus 5 divided by x square term, that is 4. So you got the answer both the same.